right? So this should all actually be the same for everybody in the class, all right? This first part is going to look the same for everybody, all right? Now, if we take a look at the next parts, step 4 of the procedure is where things get different for everybody. All right, so step 4 of the procedure on the sheet says measure the mass and volume. Your job is to actually explain how to measure the mass and volume, all right? So we want these procedure steps listed out so that anybody could repeat our experiment, all right? So we want them to take the mass in the same way that we took the mass. We want them to find the volume in the way that we're saying to find the volume, all right? So you want to make sure that you are being explicit in how exactly to do that. All right, now I have a couple of things with me. So remember that we used our balance to take the mass, or you should have used the balance to take the mass. Now, when you're thinking about writing out steps, if you say, put the metal sample on the balance, right? If that's what you say, then you're going to have people just pouring this metal sample into the balance, all right? That's not good, especially what if we're dealing with the gold-colored sample and you pour it, these little pellets are just going to go everywhere, all right? That's not good measuring procedures. Remember that I provided you with these weigh dishes, all right? So we can utilize these to actually take the mass of our sample, all right? So there's a couple of different ways that you could have done this, and I hope that you would have written this out in your procedure. You could have turned the balance on and zeroed it, put your weigh dish on there, note the mass, add however much of your sample, note the new mass, and subtract. You could subtract this final mass from the mass of just the empty weigh dish. The easier way, and probably the more accurate way really, to find the mass is that you're going to place the weigh dish on here and you're going to zero it with that weigh dish here. All right, what that does is it discounts the mass of the weigh dish. And then whatever you place in that weigh dish, the mass will show up here. It's not taking into account the mass of the weigh dish, so it'll just be the mass of the metal and you can record it. All right, so that's what you should have been doing for mass. Again, you want that procedure written out in a way that is easy to follow. Now, the next thing that you were to do is you were to, sorry, I dropped my pen earlier, you were supposed to find the volume of the liquid sample, all right? So you were supposed to find the initial volume, the final volume, and then subtract those to find the sample volume. So let's just say that for sample 1, I had a pretty small sample. So my sample was 4.66 grams, all right? Now, things to note about my data table here. First of all, the procedures are up here, okay? I'm still talking about the procedures while we're also talking about this. Notice that my data table, as much as was possible, the lines are very straight. I tried to use a straight edge to do this. You must use a ruler on this data table, on any tables that you use in your lab notebooks, all right? I have gold labeled here. That means that the sample that I used in the lab was gold, all right? If you use silver, then you're gonna write silver here. Right? So you were supposed to figure out the volume of the sample. All right, now we worked on water displacement in the measurement activity that we did a couple days ago. If you remember, the method for measuring volume with water displacement is you're going to add some water to this empty graduated cylinder. This is a 25 milliliter graduated cylinder, okay? So you're going to add water to this. Now, in your procedures, you should be explicit as to about how much water you're going to add. So I'm going to say maybe add about 15 milliliters of water to my graduated cylinder. All right, and I'm going to write that all out. That does not mean that when we get down to this initial volume down here, that we're just going to write, oh, 15 milliliters, 15 milliliters. That's how much I'm adding, right? Because we're trying to be precise. The whole point of this is that we can graph it and find trends. That means that although you're going to add as close to 15 milliliters or approximately 15 milliliters, you actually need to find the volume. You actually need to get down on your knees at eye level, find that meniscus, right? find the meniscus, and actually measure what is the initial volume that we're working with. All right, so once you've done that, so let's say I took my initial volume right here, all right, and let's see, this long line is 10, the long line here is 15, and I have 4 somewhat long lines in here. That means each of these semi-long lines are 1, an increment of 1, so 10, 11, 12, 13. I can see that this blue line, I don't know if you can see it very well, is at least 13. It's not on the 13 line, so it's a little bit above. Now I'm going to look at my small markings here. There's 1 small marking in between each increment of 1. That's going to be an increment of 0.5. Just because we know 0.5 doesn't mean that we're certain to every tenths place, all right? So just because there's a 0.5 here, that doesn't mean that I'm certain to a tenths place. If I had a tick mark at 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then I'm certain to the tenths place, and I'm going to estimate the hundredths. Here, even though we're certain to a 0.5, right, theoretically, we're not certain to every single one of those tenths place. So my estimated digit here, I know this is at least 13, my estimated digit is going to be that tenths place, all right? So I'm going to look at this, and I actually think that's about 13.1. All right, so my initial volume I'm going to say is 13.1 milliliters. Now, let's say that I add my metal sample. So that should be the next step. You should add your first sample into the graduated cylinder. And let's say that the sample volume goes up just a little bit, right? There we go. Goes up just a little bit. It's a small sample, so it's not going to increase the volume a ton. So I'm going to say this actually looks like it's 13.8. So my final volume here is 13.8, right? For my sample volume, this is the volume of water. This is the water plus the metal. So I'm just going to subtract final minus initial. Final minus initial. So here I have 13.8 milliliters minus 13.1 milliliters, and I get 0.7 milliliters, all right? 0.7, you don't have to write all of this in the box. You could just write 0.7, but I wanted to show you how to do it. So 0.7 milliliters would be my sample volume there. Now notice that if we're measuring liquid, right, we're going to have a volume of milliliters. These are all labeled centimeters cubed. That's fine, really, because we know this conversion factor. 1 centimeter cubed is equal to 1 milliliter. So there's no difference in measurement. All right, so now let's just say these are the measurements that I have for my masses and my volumes. The next thing that I have to do is I need to plot these points on my graph, all right? Now I want to look and see what my variable should be on my axes. So on my y-axis and on my x-axis. Mass and volume are 2 variables that we measured. So which one changes as a result of the other? The dependent variable is the one that goes here. All right, so I'm just going to write dv in parentheses here. Which one depends on the independent? Which one depends on the other? All right, so when we're looking at mass and volume, we're going to have mass and volume over here, all right? So that's saying that as our volume changes, as we change the volume, the mass will change as a result, right? So if we increase the size of something, the mass is going to increase. So I'm going to plot my points that I have here for mass and volume, but I need to first label my axes. So this is my own scale drawing. I use a ruler, you should too, and it's going to be easier to draw this in your lab notebook. I see that my volume, my greatest volume that I have is 3.6. All right, so I'm going to say maybe each of these is going to be 0.5, each of these long lines. 1, 1.5, 2, 2.5, 3, 3.5, 4. Your goal is to really use up as much of this graph as possible. So you do want to find a way to space these out correctly, but make it take up as much of the graph as possible. My mass, the greatest number that I have is 27. So maybe my graph is going to go up to 30. So maybe, I mean, this isn't going to take up as much as I'd like, but maybe each of these increments is going to be 5. 5, 10, 15, 20, 25, 30, 35. Okay. You want to make sure you're labeling your mass with the unit as well, grams. And the volume down here, you can either put centimeters cubed or milliliters. Now it's time to plot my points. So if I see my volume of 0.7 and a mass of 4.66, I'm going to have a point right about here. 1.5 and 11.19, right about here. 2 and 15.06, right about there. And 3.6 and 26.89. Right about there. Right? There's my points. Once I have my points, I want to draw a best fit line. So first of all, do you notice any pattern? As one increases, does the other increase? As one decreases, does the other decrease? So that's the kind of pattern that you want to be looking for here. All right? Does it make sense that we're going to have a point that would theoretically go through 0, 0? If something has no volume, does it make sense that it would have no mass also? All right, so think about that. Should there be a point through 0, 0? Or should there be a line theoretically drawn through 0, 0? I think if something has no mass, it also has no volume, because if we have matter, it has mass and volume. All right, so I'm thinking that this should have a point through 0, 0. Now, we're supposed to draw a best fit line. In order to do that, we're going to find it's easier with a transparent ruler, but you want to find a line that goes about through the middle of these. You're not connecting the dots. You're just trying to draw a line, a straight line, as best as you can, that comes close to all the points. And actually, this one did pretty good, all right? So that's like the average of all the points. Once you have the line, you can take a look at the line, and you can actually measure the slope of the line. All right, so by taking two of our points, let's say our biggest point and our smallest, right? So we'll do this one and our smallest. We can figure out the slope. The reason I'm picking the biggest and the smallest is that they're very close to the line. All right, so we can find the slope by taking y2 minus y1. So 3.6 minus 0.7 divided by x2 minus x1. I just did that backwards. Y2 minus y1 would be 26.89 minus 4.66. And x2 minus x1, we are going to have, where am I? We're going to have 3.6 minus 0.7. All right, so we can actually calculate the slope here. Once we know the slope, we're going to compare it to these values that we see up here. What one does the slope come closest to? That's the metal that you're going to assume you've been working with. Which one of those does it come closest to? Okay? So you're going to pick the one that it comes closest to. I'm not going to do the math right now, but I'm going to say that it's coming closest to, we'll say copper. All right? Now, you're going to have a slope here. You've just calculated a physical property. You need to think about, what physical property did you just calculate? What physical property looks at mass over volume? What physical property looks at mass over volume? You've just calculated that physical property, okay? Now, you're going to compare this value that you get for the slope here and this value that you're assuming is the slope of your actual metal, okay? And you're going to plug that in to our percent error equation, all right? So the observed value is going to be the slope that we just calculated, m. The accepted value is going to be whatever metal slope you came up with. So if it's copper, I'm going to plug in the slope of copper for both of our accepted values. Multiply it by 100, and you should have your percent error.